Well, happy Monday again. So we're going to talk more about functions, and then we'll get into the next project as we go as well. So we got through a decent amount of functions here. This is kind of a big chapter. So talked about pass by reference is about as far as we got, right? This idea that I will give you the location in memory where this is stored, not just here's the value for you to use, which is a copy when we pass by value. So this essentially lets us get around the idea that functions can only return a single value. It's our little shortcut there. So let me start up Visual Studio here. I probably have to clone my repository, don't I? Oh goodness, I didn't install GitHub. Uh, all the joys of a new laptop, right? But it is new and shiny, so that part's fun. Let's see. Yeah, we're going to do an example of pass by reference. So when variables are stored in memory, the variable really is like where it is in memory. Like I say, here's my name, my favorite number, and C++ knows, okay, this is where to go get it out of memory. When you pass that to a function, generally you pass by value. You say, hey, here's the particular value of that function. Oh goodness, I got to get a code. And then you can't modify it inside the function. But if you pass by reference, you say, this is where my value lives in memory, you can go and modify that. So it's kind of a workaround for that. Um, so if you have the reference to it, you can go and change it because you've changed where it is in memory in the original location. You don't have that copy here. Let's see. No. All right. Got logged in. Sweet. Hub 50. Clone our repository. I'll probably do a new project so we don't have all that junk in there early. Okay. Cool. So, oh, I gotta sign in. So many things with a fancy new laptop. Come on. It's weird.
But you got the import connection.
Diablo 4 is installed. Yep.
Baldur's Gate yet?
No, I didn't buy it yet. My son has it. I wanted to finish a couple things first before I drop some more money on that. All right, so I'll start a new project here. We'll put it in our documents, GitHub. So let's do a new project here for 5 functions part 2. All right. Is that zoomed in enough, or is that easy to see okay there? Namespace, standard. All right. Okay, we don't even need that line. So when we write our functions, right, if we want a function that returns a value, we say this is the type I'm going to return here. So I might have an int, right? I might say this is add 10 to number. That takes an int for a number. All this one's going to do, oh, I think we usually move those down one line, right? We could return number plus 10. I can change the number. Now, we could do it in more than one step, right? I can say my number plus equals 10, and then I can return the number if I want. And if I have an int in here, like my favorite number is 42, and then I can see out my favorite number. We'll see that it's 42, and then I can call my add 10 to number, and I can give it my favorite number. Right now, I'm going to give it a copy. I'm going to give it I'm passing by value. So I'm going to give it the 42 here. But what happens behind the scenes is somewhere in memory, my favorite number is stored over here. And when I pass it to add 10 to the number, it makes a new 42 in memory, maybe over here. Right? So the function add 10 to number works on this one, and as it changes it, this one over here is not changed. Right? So then if I see out my favorite number when it's done, it won't change. Maybe this is a int of my new favorite number. we can assign, right? This function will return a value, returns an integer, so I can assign it to something. So I can return my favorite number, and then I can see out my new favorite number, that direction. So if we run this in debug mode, the debug mode is going to be your friend for working through. Now that things are getting a little bigger and more complicated, you're going to want to get familiar with it, right? So come over to this gray space, put a red dot in. Right? They're gray until you click, then they're a red dot. And when you hit run, this with debugger, not the little run over there, it will pause at this line and we can see what's happening. So we can see my favorite number is 42. My new favorite number has a garbage value. Until they get assigned, they just have garbage, which is a little weird, but that's okay. So that 601 will go away. Now I want to step into my code. Right? Step into will go into my function, and I can see now numbers 42. Right? That's the argument I was passed. We can see this call stack over here in the bottom right. You can see we were at line 16, where favorite number was 42. Now we're at add 10 to number at line 7, where number is 42. And now if I want to step, I see numbers 52, but I come back here and my favorite number is still 42 because we passed a copy. We passed by value. Right? We don't have the reference to that number. So then I step, I return the number. Now my new favorite number has a value of 52. Right? Didn't change my favorite number because we passed a copy of it. We passed the value, and I've created a new variable with those values, and then I can output. So outing things is what we call like the poor man's debugger. You can output all your variables, or you can just run it in debug mode and see them. Right? You don't have to be outputting things to see what those values are. So, I would prefer to just run it in debug mode, but some people like to see it spit out on the screen. That's all. So take your pick. If I want to change that so I can modify the number variable, right? I can say, hey, I would like this to be passed by reference with the ampersand sign. Just by adding this here now in my function, when you call this function, you're going to pass the reference, not the value, not a copy of it. So now when I run this in debug mode, and we want to step into our code, we see numbers, hang on one sec. Now we see numbers 42, right? We see my favorite number is 42, right? Like we expect. Now, number has changed to 52. My favorite number is also changed to 52 because I've passed, this is where my number is stored in memory, right? So where main is keeping track of it is the same one that we've given to the add 10 to number function. So as we change it, because we have the reference, it's been changed. I can assign it. I have both 52s, right? So it stays changed when we pass by reference. By value, and you pass by reference. So in this case, this is not a very interesting, right? We're returning something and it's the same thing we're changing essentially. But if you wanted to have a function that can set more than one value, right? I could return something, but maybe then I set some other values. We can do that as well. Uh, so what's a fun one? Like the quadratic formula. You guys remember that? Where you find the x-intercepts, right? Or is it y-intercept? No, it's x-intercepts. X-intercepts. Terrible at remembering which one's which, right? Where x is negative b plus or minus the square root of b squared minus 4ac, both divided by 2a. It's not the kind of thing you should have in your head, but for some reason it's stuck in my head, right? We could do that. So that probably will return something, right? Maybe I've got a value, maybe I have some intercepts here, and then it could set other things. Right? So maybe we just have a Boolean here for whether or not even have any intercepts, right? Because you might not have any x-intercepts, depending on your equation. So this could return a Boolean of true or false, you have intercepts or not, right? So this is like find quadratic, or find x-intercepts, intercepts for quadratic. For that, you need A, B, and C, right? You need a double for A, you need a double for B, you need a double for C. And then if I'm going to set the intercepts, I need two more doubles, right? So this x-intercept 1 and double for x-intercept 2. Now this gets a little long, that's okay, but if I pass these by reference, I can set their values inside my function. No spaces there, it's yelling at me. Did I? Oh, I did. Didn't end the parenthesis. There we go. I shouldn't have to scroll left and right. I feel a little bad here. So let's just bring that down a little bit. I don't know. Something like that's probably okay. So first we need to find the determinant to see whether or not we can even take the square root of b squared minus 4ac, right? To see if that's positive. Because if that's not positive, you can't take the square root of a negative number, the whole thing fails, right? So we can check and see. So this is the double for the determinant. Determinant. It's probably close, right? That's b squared minus 4 times a times c. Now, this should work, right? If you want to add some parentheses here, it's not going to hurt anything. I'm always a fan of being explicit, right? I know order of operations will work, but why not? Why not? Just it catches your eye, right? That these things should happen first, right? Nothing hurts. Nothing doesn't do anything. Nothing wrong there. So if this is not positive, we don't have intercepts, right? Because we're going to have to take the square root of this eventually. So we can real quick check and say, hey, if the determinant is less than or equal to 0, we can just return false, right? This is a Boolean value. There are no x-intercepts, right? If it's not, right, remember this return keyword just stops our function from running. So you could put an else here, but it's redundant because if this ran, no other code's going to run anyway. If it doesn't run, well, then we're in the essentially that else section anyway, right? So then I might say my x-intercept 1 is equal to, so it's, oh goodness, negative b. So negative b plus or minus, so we can do plus the square root of. So if we want to include our math library, CMath, I think we can do square root of b squared minus 4ac, so that's the determinant. Now, all of that divided by 2a, both divided by 2a, do you do it first and then divide? I think that works, right? I think we can do it all first and then divide by 2 times a. Now, this one, your order of operations will hurt you, right? The please excuse my dear Aunt Sally thing. I swear I had a college student one time tell me that multiplication happens first because you say multiplication and then division. And I about cried. Like, you got to college somehow and you didn't understand they had the same order of precedence. It's okay. I don't teach math. It's all right. I just get to complain about it, right? So definitely required some parentheses here, right? I think we can do the plus first and then divide, right? We don't need to divide them both first. Does that work out the same? Is that the distributive property or something? It's been a little while here. My math is a little rusty. You don't actually use a lot of math. So depends on what field you get into, I guess. So my brother's best friend in college got a whole master's degree in learning how to draw a curve, and now he works for AutoCAD. It seems terribly mathy and dull, and I was not interested at all. I don't do any math at work. So, right there. Depends what you do. All right, so x-intercept 2, right? Same thing, but now we will say minus square root of b squared minus 4ac, right? And then we can return true. So we'll set those values and then return true. So we've essentially returned more than one thing, sort of, right? So we can try that then. So we can make some variables then. And we can even ask the user, right? Why not? Because we love asking our user for things. So enter values for A, B, and C for the formula A. Oh, that should be little a, right? Little a, little b, little c. I don't know. A x squared plus bx plus c. That looks weird now with the x is capital. I don't know. I don't type math very often, right? Now here's a fun little thing. Remember when we did get line, it got the entire line up to an enter key. When we did cin, it just went up till it found some spaces. So you can cin A, B, and C. Can we do that? How do we do that on one line? Cin. Oh, we just do cin A, cin B, cin C. I think we do them on one line. My goodness. All right, I need to tell C++ their doubles first. Uh, you might have seen this. I don't like this, where you can declare them all in one line. I think I mentioned that once. I just think that's a little ugly here, so I try not to do that. But if you like saving lines, go for it. Uh, you can say they're all doubles and just comma separate them. My keys are not working right here. There we go. Can I do A, B, and C? A, B, and C? No, I don't think that's going to do what I want it to do. That looks bad. C and B, C and C. Right, and we also need doubles for x-intercept 1, intercept 1, and a double for x-intercept 2. Okay, and then we'll check and see if there are intercepts, right? So if my find x-intercepts for quadratic, given A, B, and C, x-intercept 1, oh, x-intercept 1, x-intercept 2. If that's true, right, I can see out the intercepts are x-intercept 1 and comma x-intercept 2, and that line. If it's not true, right, this whole thing here will give me back a true or false, so I can use it in an if. My function returns a boolean, true or false, so I just throw it in here. It's either true and the if runs, or it's not true and the if doesn't run. Else we can see out there are no intercepts. So I don't want to use the values of x-intercept if I didn't set them, right? You get those weird garbage values. So we just got to be careful that we make sure we only use them if it's true, right? If we do have intercepts, right? So let's give it a try. Why did that B look? Okay, it did turn blue. There we go. All right, so I can take off the breakpoint here. Let's hit continue. And now we get to the prompt. Enter the values for A, B, and C. This is the little shortcut. Because it uses spaces to separate, you can say like 1, 2, 3, space, 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 and hit enter. You don't have to do 1, enter, 2, enter, 3, enter. You can do them all in one line if you want. That's just for fun. All right, so how about some values that do have intercepts? Right, what is it like? 2, uh, b squared minus 4ac, so -2 and like 1? I think we'll have intercepts or something like that. Nope, that's a no. Where's one that has intercepts? 2x squared, it's like minus 8x plus 1. That one's got to have intercepts. There we go. And it gave me some numbers. I don't know if those are right or not. So let's go over to, was it Desmos? You guys use Desmos? This one's really fun. Graphing calculator. So we said 2x squared minus 8x plus 1, right? I think those are 2, 8, -8, and 1. And we get 0.129 and 3.871 that we had. I think we're pretty close. It worked. We found some intercepts. So we were able to set values, essentially, right, inside the function because we passed them by reference. All of that for a pass by reference example. It was very exciting. Yeah. One more time. We could have output them inside the function here. We would not have been able to use their values here later in our program. So having the double here, they would not be able to be set. So if all you're doing is outputting, maybe that's fine, but maybe we want to use those values later for some other formulas. I don't know what other stuff you do with curves and math and why you need x-intercepts, but apparently it's really important we find x-intercepts of parabolas. Does anyone know why we have to find x-intercepts of parabolas? Like,
That's the highest or lowest point on the parabola. Oh, no,
the intercepts. No, it's not like the local min or local max. Those are fun. Like, we do that in calculus, but like, I don't know why we spent so much time finding these intercepts. It does. I don't think it has slope, right? Because it's a parabola. I don't know. Go ask your math teacher why these are important. I think they're just easy places to solve. So they just give you points of reference for graphing. Okay, so we can sketch the curve. Okay.
Right, not the slope of the parabola, but the slope of the line tangent through it or something like that.
That sounds mathy.
Yeah.
Yeah, sure. So we can do fun stuff, right? So that's passing by reference. All right. All that for a math example you might remember. Okay. So other fun things then with functions. So we haven't gotten to vectors. Don't worry about it. We'll get to them later. That's in a different chapter because why? And the order of these sometimes gets weird. We get to that in chapter 7. We'll get there. So don't worry. I don't know. We'll get there. But strings, remember, strings are mutable. You can change strings, right? If you have the reference to the string, right? So I think we said, hey, if you want to, let's say this will just be, I don't know, a void function. It doesn't need to return anything. Uh, uppercase string. Given a string for, and we should include string, string, some string. Sure. I think we put all those down here, right? Some people love curly braces at specific places. I don't really care. Uh, so I could take each letter in my string and make it uppercase because it's mutable, right? One at a time, one letter at a time. Let me get the length of a string. Plus of string. Text.length. Okay. Or size. Length or size. Oh, sure, they both work. Cool. So we can do a little loop, right? We can say for index is 0, index is less than some string dot size. Looks like size was suggested here. Some string plus plus. Nope, 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 no, no. Index plus plus. There we go. So starting at index 0, right? It's going to be the first character, right? When you take one character at a time, you always start with 0. It'll make more sense when we get to arrays, don't worry. As long as we're less than size, so Eric has 4 letters in it, there is no index 4, right? Because it's index 0, 1, 2, and 3 in my name. So less than size will make sure index stays less than 4 for a 4-character string, right? So one character at a time, then I can get out my sum string. Was it dot at? At will give me the index, right? So that'll be the character at that specific index. Right? We can take that character and then we can change it. So maybe I want to change to upper of that same character. Right? So start at index 0, change the value of it, assign it a new thing of the uppercase version of the character at that location. So if I give it Eric, it's going to find the E, uppercase the E. Find the R, uppercase the R. Find the I, uppercase the I. Find the C, uppercase the C. Right? And then when we're done, we can see out uppercase, cased, I don't know, sure, and some string. So we can, we'll do that at the top, right? Why not? So we'll have a string. Oh, we can even ask them, right? So a string for name, and we can see out enter your name, and we can see in on name, and then we can call that function, right? Uppercase, what did I even call it here? Uppercase string. Uppercase string, given name, and see what it does. Right? It's a void function. It should output something. And then when we're done, just for fun, we will also see out name. This is name in main. So we can call our function. It should turn every letter uppercase, spit it out, and we'll see what happens here. So I'll put a breakpoint in because breakpoints are fun. Right? We can watch it in debug mode. All right, so enter your name, Eric. And I want to step into my function. I don't want to step over. I want to see what's happening. So we see some string is Eric. Index is 0. Sure. So we're going to loop through. We uppercase to the E. Well, nothing changed. That was kind of boring. Now the R got uppercased. Hey, something happened. Now it changed here. Again, it's a little small down here. Sorry. And then the I gets uppercased. And then the C gets uppercased. And we spit it out. Function's done. And my name in main stays lowercase, right? Because we've passed the string by value. We haven't passed a reference. Just like with numbers, when you pass something by value, you're getting a copy. So it changed to the copy we gave it, which is a new location in memory. not my original. So if you want to change the original, sure, you can do that. We can go say, hey, let's pass this thing as a reference. Now, if you're paying a little bit of attention here, when you hover over your function, you get this cool little IntelliSense pop up. You'll see that it's a string reference. You'll see the little ampersand sign in here. String ampersand some string. Maybe you'll notice that you're passing a value by reference. And if I take it out, right, and I hover over it again, now it's just string some string. So if you know what you're looking for, you can tell that this thing is asking to be passed by reference or not. If you know what you're looking for, right? Just sometimes you pay attention, sometimes you don't. So if I do it this way, and we step over, let's do Eric again, and then we step over. Now name has changed, as you'd expect, because I gave it the reference. It knows where this thing lives in memory, so it changed to the original. Right? Sure, that's fun. All right. So that's with strings. Right? This was changing spaces to hyphens. Sure, why not? So it looked for, hey, if you found a space here, it set it to a hyphen. Why not? The vectors, we haven't got there yet, so don't worry about those. That's weird. But that's okay. If you don't want it to be modified, you can use add a constant keyword to your argument. So you can say this is a constant something here reference, and you're essentially promising not to change it. It's one way. It won't make a lot of sense till we get to vectors. So I don't know why they kind of mix and match on us here, but that's okay. And then lots of practice, of course. Now, they also have these char types, which are arrays. We haven't got to arrays yet. The layout of this confuses me. I apologize. I didn't write the book, though. Um, this char and these square braces are this meaning array. A char array is a C string. The original C language, not C++, didn't have strings. It had character arrays, which are C strings. I know it's fun like that, sure. Um, don't worry about it. We can come back to it later. All right. Did we do talk about scope of variables? Declaring variables inside of functions and outside of functions? Did we talk about that? No? Okay. We didn't talk about that. That's fine. So if I want to use a value in, I thought, no, we did, right? Because we had constants outside of all of our functions. We could use them inside the functions. We did that, right? Pretty sure we did that. Okay, I can check GitHub. Yeah, yeah. So the scope, this idea of scope. So this scope here is scoped to my uppercase string function. There's also the global scope, right? The bigger scope that I can declare variables at, right? So I can have an int for my favorite number. It's 42. This is the global scope. So my favorite number now exists everywhere. You can access it in all of your functions. Now, I'm going to argue that the global scope is ugly and we shouldn't use it. There's times we need to. In general, it's a little bit ugly. So I will try and avoid using it best I can. Constants maybe are fine here, but once we get to classes, we'll figure out a better way to do all this sort of stuff anyway. We'll get there eventually. So for now, it's there. Try not to get into the habit of using lots of things with global scope. If your function needs a value, you should probably pass that value, not declare a bunch of things as global scope and then use them in your function. Uh, that's unless they're constants. Constants are fine to put out here, sure. Um, but other than that, it gets to be a little bit messy here. So when I have int my favorite number, let's change this one to 777. It's actually that's my wedding anniversary. We were able to pick a fun date, so that's a pretty good number too. So int my favorite number at the global scope here, and then int my favorite number 42 over here. So when I run my program, enter your name, it's Eric. That's fine. I want to step over. Now I have my favorite number is 42. Oh, I stepped over too soon. I wanted to go back one. Run that one more time. So your name is Eric. There we go. So my favorite number doesn't have a value. Right? I've declared this thing up here, my favorite number, doesn't have a value. Now it's got a value that I set here. Gotta be a little careful. Let's try and make this a constant here. Your name. We still don't have a value for my favorite number. Right? I'm not using that other value there. It's to be a little messy. Now it's 42. Right? So obviously this is not the same my favorite number. Right? If it was the same my favorite number, by saying this is a constant, it would give us an error that you can't assign it twice. Right? It it'll get upset if you try and assign it twice. So you gotta be careful. Um, Now we can use constants in here, like in our formulas, are pretty handy. Like this centimeters per inch, 2.54 inches per feet. These are terrible variable names, by the way. Right? You should spell these things out. Per in per foot. Like it's not hard to say inches per feet, but sure. I mean centimeters is a little bit longer to type, but yeah, it's not the end of the world here. So those are global variables. Right? You can do those sorts of things. Like they said, they're hard to maintain. So we try and avoid them here. But constants are generally accepted. They're okay. You can do some constants. Um, and then when we name constants, right, they're all uppercase with underscores. These be a little funny here. Uh, um, Function has a scope. Yep. Uh, if you want to not have to declare all your functions at the top, remember, if I tried to use a function that didn't exist yet, that was written below main, it got upset, right? If I put this down here for add number, I get a build error, right? It's not even working. Oh, where'd my error list go? Error list. There it is. No, didn't even show me. There it is. Add to 10, add 10 to number, identifier not found. It doesn't know what this is because it's down lower in the file. If you like doing more work, you're welcome to use these function prototypes. The function prototype is the header of the function written up above in your file with a semicolon because that makes sense. Here's a function prototype. Prototype.
That's how Python did it, or at least we did it in Python, because we have the prototype up top and then at the bottom we have the actual function. Had I known that you could just write the function above with the name and stuff, and
Yeah, this is my least favorite thing to do because you can tell I'm lazy. So why would I type this twice? But if you have your prototype at the top with a semicolon, you've told C++, hey, I'm going to have this thing here in my code somewhere. You can go find it later. But now, because we've declared it first, C++ is like, oh, sure, you're good. I know you'll get to it eventually, and then you can use it, right? Yeah, um, I think they're dumb. Some people love them. Sure, whatever your preference. Um, like if you're gonna do it, why not just write the function here? I don't know. I'm awfully confused by these. Uh, that's all. But you can put them up there if you want. Some people love this sort of style to declare them all at the top. Later, when you get into bigger and bigger and bigger and bigger C++ programs, these sorts of things sort of matter. And by sort of they actually do, but you need a really big program for it to matter. And once we start talking about multiple files and things like that, it'll make a little bit more sense. But it's fun. All right, default values. This one's super cool. Default values are really fancy. So if I have a function and I want to say, hey, unless you tell me otherwise, I'll give you a default value. Right. So maybe we have a function for this is I don't know, print date. And we'll say, hey, you tell me the month and you tell me the day, and you can also tell me the year if you want. But I'm going to say, if you don't tell me what the year is, I will default it to 2023. Now, as you can imagine, this code would be horrible to maintain because you'd have to go change this every year, which would be stupid to have to do. But just for the sake of exercise now, I can call print date here, and I can say what is this? The American format is going to be month slash day. Oh my goodness, I can't type slash year, right? Two of those. This key, I have to get used to the new keyboard here, sorry. And then the European format is day, month, year, right? Because they go smallest to biggest. Makes sense. But the best format here is the ISO format, our International Standards Organization format, is year dash month dash day, which is the superior format here. Um, because when you list all these out and you sort alphabetically, they actually sort by date. Because you get the year and then the month and the day, and things will actually sort alphabetically, which is super nice. Uh, so that's why it's the best format. But again, that's okay. So when I call print date here, I can just call the function. I can say, hey, let's print 10 and 9. And it's telling me, hey, the year is defaulted with this little IntelliSense here. Or I can print the date, right, 7/7/2007 if I wanted to print my anniversary, right? I can give it a year if I want. It's optional because it has a default value, right? And both of these will work here. If I just put a little breakpoint and then step over, we can see we get the dates printed out in all their glorious formats, right? Now, month and day, if they're the same, don't look different between European and American. Go figure. Um, but these will confuse people very quickly if you don't specify what date format it is, right? Because they both look like valid dates in both formats. Uh, so default parameters are awesome for how you wanted to do that. Yeah, they can give you a specific style if you want, so you can pick which style you want. That's always fun. And then if they all have defaults, right? You can default all of them. I don't know why you would, but you could. You can print with any sort of different combination, right? Where I give you all the values, I give you three of the values, two of the values, one of the values, none of the values, those sorts of things. Those ones are fun. Another thing you can do is you can have more than one function of the same name if you have different parameters. This gets to be kind of fun too. So what we generally do with this is it makes our functions easier for other people to use. So when we're writing functions just for ourselves, it's not very interesting. But if we're writing a library of code for someone else to use, we're like, hey, I'm going to write some awesome code. I want lots of people to use it. You want it to be very friendly and easy to use. So your print date, this one takes integers, right? You might also write a print date function that takes strings for month, string for day, string for year. And then that defaults to as a string 2023, right? This does literally the exact same thing here, but now when I call print date, I can call print date and I can give it now. It says, hey, there's one of two. There's ones with ints here, and there's ones with strings. So I can give it October 9th here, sure. I print the date. Now this is going to come out really funny with strings when I start changing the syntax and add in slashes and dashes and things. It won't do anything proper. So this is just an exercise here. But you can have overloaded functions. So this is overloaded. Same name, different parameters. That's what this one is. So you can have more than one function defined. Like this one, where did they go here? Yeah, they had their print date. They're using the same one here. That one's fun. Parameter error checking. There we go. Those are fun. Sure. So we could make sure we get good values in here. That's kind of handy. I think if A is not, or if A is 0, we don't have a quadratic formula. It's going to be a little silly. It will probably still work. I think we can still find an intercept, right? Even if A is 0, but it's not quadratic. So maybe we could check in here and say, hey, if A is equal to 0, we've got a problem here, right? I don't know, C out. That's not quadratic. Now, outputting things in functions is not always my favorite. but that's okay. We'll get to that later. You can just do some checking here, right? If you want, and figure out whether or not it's good or bad for specific values. Look at this. It's not just me. This is the hash symbol, not a hashtag. Hash symbol. Sure, that's the symbol. Pound sign. The book has gone beyond me now. I'm stuck in the past. But it's not a hashtag, right? Without the letters, right? Just this pound sign, right? Not a tag because there's no words. Just so you can, be pedantic and argue with people about they're using good words here. So include is fun. So far, we've included libraries here, built-in libraries. What we can start doing now with functions, like this uppercase function, right? I think someone had asked, is there a way to uppercase a string in C++? And no, there's not built out of box, but we can write our own here. Now, you probably don't want to copy paste this everywhere, right? If you have the same code twice, you should feel bad about yourself. Don't copy paste yourself either, right? Across your different projects. Now, that gets to be a little bit messy, but what we can do is we can add a new C++ file and we can include our own files. It's super fun. So we can have things declared in our files and then go import them ourselves. Now, generally, we put them in H files. H is a header file. There's reasons around this. We'll get into them a little bit later, but instead of a source file, I would add a header file, right? So far we've done everything in source. I go to header files and I can add a new item. Let's call this, I don't know, my string functions. I'm going to paste my string function in here. Nope. This one. I'm going to cut that out, paste it in here. Except I need to add all that other stuff. Include string and using namespace. Now, this gets to be a little bit ugly as well. Include IOStream. Having other code and includes and other things inside of your own files, when you include another file, it's essentially running it all, and now we'll have this more than once. It gets to be a little bit weird. I'm not too stressed about, oh, give me the wrong name here. That should be an HPP file. There we go. This is an HPP, so H++, the original .h files were for C, so you would have C files and H files. Now we have HPP and CPP files. It really doesn't matter. Not that important one way or the other. But now over here, I don't have this uppercase string, so I could go and include. I can say I want to include, and then if I put in quotes, IntelliSense says, hey, I see a file here in your project. Do you want to use that one? Right? Just by putting in the quotes. Yeah, I want to include that one. And now it's happy. Now I can use that uppercase string function from another file. Now what's cool is I can just keep this file around and include it in lots of projects. I don't need to add it to every individual file here. I can just have it once. For my case, I'm going to have one repository with a bunch of stuff in it, which is okay. For all of your projects, right, you get a new repository. For all your labs, you get a new repository. You pretty much still have to copy paste this file around. It's not very exciting, right? But maybe that's slightly easier than copy pasting the code into your project. But then you have that file lots of places. It's still not great. There's other things we can do later on. We don't even get into it in this class that deals with how you make these things into packages that you can reference a package lots of different places. Hopefully you're going there that it's really annoying to have this file lots of times. So having this in a nice package and be able to include that package would be great. Like we include the library functions. We don't get there. Sorry, we just don't have time to get into all that fun stuff. But I can put it all in my HPP file if I want, my header file, and just keep all my fun little functions in my header file and keep that file around. Right, so then you can just include your file. So keep this including files idea around. We'll come back to it when we get into classes near the end. Because that's my preferred way of dealing with classes because it helps keep things organized and clean and pretty and lots of fun. So you can do all those if you want. They're fun. So this separate files idea. Now, technically, your H files should just have the prototypes, and then you would have a matching CPP file with the actual functions in them. All you have to include is the H file. I hate doing that, and then it's going to mess things up for me later down the road. Um, so this is the more proper way. What's cool about doing it this way is as your projects get bigger and bigger and bigger and bigger, when you hit this little build button or when you hit run, you notice it goes through and does this build started. You can also go to, oh goodness. Oh, did it not actually work? Use one or more multiply symbols. Oh goodness. Already defined. Uppercase string. I broke it. I did. Okay. It's not even working with me now. Include my string functions. Symbols defined. Uh-oh. Huh. Uppercase string. Well, that is the problem. Bummer. Did I not build? Let me try one more time. Nope, still failing on me. Goodness. Already defined in functions too. I have to add something here. One sec. There's a line I have to add. Yes. You can add these header guards. So as you include things, it says, hey, if it's not been defined, go and define it. Like when you create the function gets defined, and then we can use it. You can add these. In Windows land, we get a shortcut. I think this shortcut will work. Let's try it here. Uh, is it pragma once? Hang on. Oh goodness. C++ pragma once. Where is it here? Oh, with the pound sign. There we go. Pragma. See if I can spell things right. Now let's see if it runs. Nope. No semicolon. Nope. Come on. I lied. It's not going to work. Okay. We'll go back and try it the hard way. If not defined. It's the worst. I hate these. This is string functions H. Then end if. Is that going to work for us? Still didn't work. All right, I broke it. Let me try adding a file here. Sorry. I shouldn't have to do this the long way. Functions. String functions. Functions. One of these things ought to work for me. Nope. Specify more than once. Extras ignored. All right, I'll find out why that's not working. It's going to bother me for a little bit. Hi. We'll come back to it. All right, should we talk about the next project? We can forget the multiple files. This is why I hate multiple files anyway. All right, so next project. So we are going to build a little game here because I like little computer games. They're fun. I have project one. So we got 2 weeks for this one. Right, where's my, no, I don't want to save date. There we go. So we'll go till class time.
Probably two.
Two, yeah, thank you, two. And we'll probably do 15 points for this one. So it'll be worth a couple more points. We don't get to get rid of anything from before. So we'll turn in the website URL. All right, go to classroom, GitHub, get you a new repository. 50, 50, project two. plus emergency alert system test. That's fun. I thought we did that last week. Nice. Okay. This is a test of the emergency alert system. I acknowledge. All right. Please submit the URL of repository, with screenshots of it running in the README, and a self-eval using the rubric. Super exciting. Okay. So we're going to write a Hangman game. Now, I'm aware Hangman is a popular game for children, but it's also a popular game for learning how to program. So if you just go search C++ Hangman, I know there's solutions out there. Right? The goal is not getting any working Hangman here. We're going to be very specific around, we're going to use functions in very specific ways to practice functions. The idea is we want to use a lot of functions, right? Okay, because we like functions. So give me just 1 second here. I need to go copy paste because that's how I roll. Let's grab this one here. Hangman with functions. Something like this. This will be close. This is going to look a little bit different. So we don't have this one here. So the word list is not going to work out super well for us, so that's okay. Rubric. There we go. All right, so using functions. So we're going to have a function for get word returns a word from the user. Ensure it's at least 4 characters long. So when you get a word for the user to guess, make sure it's a long enough word. Right? Guessing 3-letter words is really hard in Hangman, and it's not very fun because it's near impossible to guess 3-letter words. So at least 4 letters. So our function get word needs to return something, right? It needs to return that string and then make sure it's long enough. So if it's not long enough, keep on asking it for another word. Right? Enter a new word, those sorts of things. We can do some checks, right? We're going to have a function for display hidden word that prints on one line a blank if you haven't guessed the letter, or the letter if you have guessed it. We're going to give it 2 things. We're going to give it the string of the hidden word. Here's the word you're guessing, and you give it a string of all the letters that you've guessed. Right? Right? We loop through a string with our upper. Well, eventually we did. See if I can get it to work here. Looping through the string, starting at index 0 up to the size of the string, 1 letter at a time. You can loop through your strings, 1 letter at a time. Right? So if you've guessed the letter, print the letter. If you haven't guessed the letter, print a blank. We're going to write a function get letter guess, given the string of the letters guessed. Don't let them guess a letter they've already guessed. Right? If you've already guessed an E, I should not be able to guess E again. So we have to check all the letters that are in the letters guessed to make sure we haven't guessed it, right? And then also make sure it only is a single letter. I can't guess Eric, right? Because that's more than 1 letter. So the size again, right? We're going to write a function for has the word been guessed, given the hidden word and the letters guessed. It'll return a true or false. True if the word has been guessed, false if it's not been. Right? If you've guessed every letter, you've guessed the word. Right? If there's a letter you haven't guessed the word. We're going to write a function for print gallows, given the number of incorrect guesses. You'll print the gallows with the correct number of body parts, right, based on the number of incorrect guesses. The number of incorrect guesses equals your body parts on the gallows. It's a really weird game to teach children, by the way. Like, I don't know, but sure. And write a function, has person been hanged, given the number of incorrect guesses, it's just true or false. So, and the game loops until the user wants to stop playing. It's essentially the letters guessed is a string. My hidden word is a get word. Number of incorrect guesses is 0. And while not has the word been guessed, this is a little, so it's Python syntax, sorry. And not has person been hanged, right? So, and those are in parentheses, right? And then we use curly braces because C++ is fun like that. We'll display the hidden word, given the hidden word and then the letters guessed, a semicolon, right? We love our semicolons. Then we'll get the letter guessed, given the letters guessed. If let's see. So this is different. Oh goodness. So we have to check that, right? So that's gonna be a little harder then, I guess. We can do that. Fine. Check if the letter guess is in the hidden word or not. So somehow, right, you have to do that. Any way that you're going to do that, right? Eventually, right? If yes, then your number of incorrect guesses goes up by one. If not, you print the gallows, given the number of incorrect guesses, and we just keep on looping, right? That's one more step you have to do. That's okay. It won't be too bad. You can even write a function for it if you want. I'm sorry, what? Yes, yeah, the gallows. So I think I had where I didn't copy it for you here. Where did my gallows go? Oh, I had it in this one. Let me go borrow that. So here's the gallows right here.
Okay.
Here's a fun little gallows. Where should we put him in here? Put down here. Right. This is easy. ASCII art style. Right. You can figure it out from there. I'm assuming. Right. So here's your example gallows. Right. And now the man has been hanged. He's having a bad day. Um, Again, a really weird game. Really weird. Um, Awkward. Okay. But that's sort of the flow. So again, the goal is not just find any hangman solution. I know there's a bunch out there, right? I want you to practice with these functions. We're going to write some very specific functions here, right? So one, two, three, four, five, six functions, right? Actually, let's do this. Let's add another one. So if uh letter guessed is in hidden word, given the letter guess, or given the guess and the hidden word. I'm sorry, I'm using the underscores here because this is Python. Is it okay? Is that going to mess you up too much if I leave that? Do you want to see it with the camel casing? Okay, you're all right. All right, cool. So then we'll have one more function here. Our guest. Write a function is. Maybe we should call that is letter guess. Letter guessed in hidden word. I like that. I like is. Okay. Turns true if the guessed letter is in the hidden word. Otherwise false. Right? Is that okay? So we've got one, two, three, four, five, six, seven functions here we're writing. Okay, lots of fun. So let me go save this. And then the rubric here is going to be 2 points per function, and then one that it actually loops and plays a game. Does that sound okay? So this is for project 2. So this is, goodness, get word function. Function. 2 points. This is the super exciting part here. What was the next one? Get word, display hidden word function. Um, cool. Get letter guess function. 2 points. Again, sorry for the camel or the underscores here. I feel a little bad now. Uh, but I think you can figure that part out. Right? Is letter guessed in the hidden word. So hopefully you're seeing here just a little bit of we're taking a big problem and breaking it down into smaller and smaller and smaller and smaller problems, doing my favorite thing ever, functional decomposition. Has anyone used that buzzword yet in a conversation just to see what people say? Not had a chance? Oh my goodness, you're missing out. All right, is letter guessed, has word been guessed? Print gallows. So by making up this into a bunch of different functions, we sort of break it down into a bunch of small problems, right? You don't have to solve a big problem. You can solve a small problem, right? And then one more here for game loops till the user wants to quit. That should be like a free point by now, right? A little play again loop. Super easy. All right. So 15 points here. Write all of our functions, right? It should play hangman. and it's something to do. So if you're typing in the word and then guessing it, it's really boring. But like have someone else type in the word for you. The get random word is fun, but we don't know what vectors are yet. So if I give you a bunch of vector code, it's going to be really weird looking. But eventually, once we get a couple more chapters in, I'll show you can get a random word out, and then you can actually like play Hangman by yourself when you're bored. So very cool. Questions, thoughts, concerns? All right. Um, so that'll be our project, and we've got one more session next week, or no, on Wednesday on functions. We got a lab today. We'll practice more functions. We'll do more pass by reference sort of things, a little bit more interesting functions, functions with default values, sort of the fun stuff with functions. I'll figure out the multi-file thing. I don't know what I did. C++ is dumb sometimes. Um, and we'll go from there. Let me change the name of this. I like having names. This is functions. Hangman with functions. All right. You folks take care. I will see you this afternoon.